Okay, so we are halfway through another week. Next Friday is, of course, the end of the 6 weeks, so please be paying particular attention to these final grades that we have, especially which is happening tomorrow. Your exam. Okay, so the exam is going to cover 3 topics. Graphing rational functions, where you're going to find all the characteristics of a rational function from the intercepts to the asymptotes, all that good information. It's also going to cover rational equations, like we did yesterday on the focus activity, and rational inequalities, where you'll solve using a sign chart, like we did yesterday on the exit ticket. I'll be passing those back in just a little bit once I get you started on the problem. Okay, just a couple reminders. If you do have any last minute questions, I'm here at 7:45 in the morning, one last morning if you want to come in, get a few more pointers or maybe some help before the exam. Is anybody making use of the resources I placed on the website? Okay, so some hands are going up. Fantastic, fantastic. If you do have any questions about those, let me know. Friday is the deadline by 8:05 if you want to go ahead and retake the graphing rationals quiz from last week. The only thing, you got to have the assignment with it done. Okay, if you want to bring it at the same time, that is perfectly fine. If you're having trouble with the assignment, again, come on in. I only had a few people come in this morning. Then next week, we have 2 lessons left in the current grading period. We have compositions of functions, inverses of functions. That's how we'll wrap out the 6 weeks. By the beginning of the second 6 weeks, we should be able to start trigonometry, which is going to be the majority of our school year. There's a lot of information to talk about. So that is our plan. Any questions? In fact, you have a homework assignment, which is due Friday. So that's going to be the first homework assignment that's applied to what I'm calling the point bank. Okay, I think I'm going to go ahead and give you 4 points for anybody who turns it in on time Friday. And you can apply those to any grade. Okay, probably a test is what I'm thinking for a lot of folks. Okay, but let's see what we were talking about yesterday. All right, the difference quotient. So this is a purely calculus lesson, but I wanted to go ahead and kind of give you a preview of what was coming because derivatives are a really important topic when you get to calculus. I believe I mentioned yesterday, applications. The first derivative will give you velocity. Second derivative is going to be acceleration. I'm not going to worry so much about the applications. I'm not going to be showing you the shortcuts. We're going to be using the difference quotient. But what's nice, the more functions you find the derivative of using the difference quotient, if you really start looking at the function and the derivative, you're going to start to notice patterns, and it's going to be easier for you to figure out what that derivative's got to be. Okay, let's see here. What will a derivative do for me? It's going to help me find something. Okay, so find what about a tangent line? The slope of a tangent line at a particular value of x. Now, every class was kind of different yesterday. Did we get to do the x squared problem, or did we just derive the... We just did the derivation, so we haven't actually worked one yet. Okay. So, big picture, the derivative, for our purposes, is going to help us determine the slope at a specific value of x. Because if I'm looking at, say, this curve here that I have f, okay, the slope at this particular value I have here would be different from that one, and so on. Okay, it's not like a linear function where the slope is constant. Here, the slope is constantly changing. And the derivative is going to help you figure out what the slope is at a particular time. All right, so let's actually try one of these. And let's start with a very simple function. This one's not in your notes, but it's going to be really easy to kind of get a good example. The quadratic parent x squared. Okay, so here's f of x. I'm going to say this is x squared. Okay, now here's my difference quotient. F of x plus h minus f of x, all divided by h. Now, what you're going to notice by the end of the class today, really, this is just relying on your good old algebra skills. Okay, being able to expand binomials, combining like terms, all that good stuff. Once you simplify this expression as far as you can possibly go, your last step is to take the limit as h approaches 0. And you may remember yesterday in our derivation, Okay. I went ahead and took 2 points on a secant line, and I said I was going to take this point and slide it along the graph until it merges with the other one. So if I were to move one point to the other, what's happening to the horizontal distance between them? It's shrinking, or as we say mathematically, it's approaching 0. That's why we take the limit as our final step. Okay. Well, what's the first step if I want to find the derivative of any function, and I'm using the difference quotient? Well, you want to find f of x plus h. Okay, so I'm always going to do this over to the side so we know that it's a separate expression. So f of x plus h. Now let me take a step back for just a minute. When you're dealing with function notation, if I gave you f of x equals x squared, and I said, okay, find me f of 5, well, what would you do? Yeah, you'd plug in 5 and you'd be able to get the corresponding y value, right? So the same thing here, only we're using a binomial. If I want to find or determine f of x plus h, what am I going to replace every x with? X plus h, that binomial, right? Okay. So my function is simply x squared. So this first one would become x plus h squared. That's my first step. Every unknown, every value of x in my function, I'm going to replace it with x plus h. Now, I want to expand and simplify as much as possible. What is x plus h squared? X squared plus 2xh. There we go. X squared plus 2xh plus h squared. Now, you'll notice there's no like terms. There's nothing for me to do here, right? That's the expression for f of x plus h. So I'm going to take him. Okay. Now, according to the formula, once I have f of x plus h, I'm always going to subtract f of x. Well, all I'm going to do here, you're always subtracting the function you're trying to find the derivative of. So I'm just subtracting x squared. And this is all over what? H. Okay. So remember this first part right here, this is f of x plus h minus, and this right here is f of x. Okay. See, I'm just applying this identity to the function that I have. Okay. Well, do you notice anything in that numerator now once I subtract the x squared? Okay. The x squareds are going to cancel, right? X squared minus x squared. Boom, boom. Now, there's nothing else, but I can still simplify because I've got h's in the numerator and the denominator. So what I want to do, the binomial that's now up top, I'm going to factor out the h. Well, what would that leave me? 2x plus h. And this is all over h, right? Well, now that I'm multiplying, what can I do with those h's? I can cancel. Now, is there any way for me to continue simplifying that expression? Can I do anything else with 2x plus h? No. Now, once you've gotten to this point where you can't go any further, this is when you take the limit as h approaches 0. Remember, h represents the horizontal distance between the x's we chose on my graph. So it's kind of hard in the beginning, but essentially any term that still has an h basically disappears. Okay? Because think about it, that value is just getting smaller and smaller and smaller. Okay? What if I were to take 5 and add it to 0.0000000000001? It's easy enough to do, right? But essentially, couldn't a lot of people just say 5? Because how ridiculously close is it to 5? And that's the idea. The value of h is going to continually get smaller and smaller and smaller until it becomes so small it's insignificant. So basically, he goes away. So what's the derivative of x squared? It's 2x. Now, there's a lot of ways to write the notation of a derivative that Mr. Heinrich is going to have you do, but what I'm going to have you do in here, I'm going to have you put a little tick mark on the function notation. So f prime of x, that's going to refer to our derivative. Okay. So the derivative of x squared is 2x. Okay, so that's all we're going to be working on. Okay, just finding that derivative. But I do want a couple of problems, want to make sure you understand what this is doing for me. Okay, what will 2x provide for me? What will it help me determine? Remember, think about the definition at the top of your page. It's going to help you find starts with an S, slope of a what? Tangent line. Okay, so here's my function, x squared. Okay, let's say I want to know when x equals 1, here's the corresponding point right here. Well, there's the tangent line. Imagine it touches it. Of course it did. Imagine that it goes through that point. Okay, so let's say I want to find the slope of that tangent line when x equals 1. Well, all I got to do is plug 1 into here. What's 2 times 1? 2. So I know the slope of the function when x equals 1 is 2. This is what you're going to come to understand as instantaneous rate of change. Because as you're going through the function, the slope is constantly changing. So this is only going to provide you slope at an exact point. Okay. As I continue to move around the function, okay, different tangent lines are going to have different slopes. But I would find them all by using this expression. Okay. Does that kind of help to make it a little better? Okay. Let's try another example. Now let's go to the problem, the first one we have on your paper. F of x equals 3x squared minus 5x plus 4. Okay. I want to find the derivative of this guy. So here's my difference quotient. F of x plus h minus f of x all over h. Now remember, I only take the limit as h approaches 0 once I've completely simplified that expression. Okay. Well, what's the first thing I'm always going to do if I want to find the derivative using this difference quotient? What was the first step we did on the previous problem? Okay. Xavier? Simplify what? Okay. So what's my first numerator I need to look at? F of what? What did I just circle? F of x plus h. There we go. That's what you want to find first. Always determine the expression for f of x plus h. Okay. So what am I actually being asked to do here? What do I do with the x plus h? Plug it in. Now, last time this went a lot faster because I only had x squared. It was a much simpler function than the one we're looking at. But every x, I'm going to replace with x plus h. So 3x squared becomes 3x plus h squared minus 5x minus 5x plus h plus 4. Okay. Does everybody see what I'm doing? Now we simplify it as much as I possibly can. Now, when you're using the difference quotient, you're going to see a lot of equivalent statements over and over again. Like this one, x plus h squared, more than likely you'll see him a lot. We know this is x squared plus 2xh plus h squared. Well, the reason I just went ahead and wrote it above is because I still have to do what? Yeah, I got to distribute the 3 after I expand that. So somebody help me out. What would that look like? 3x squared plus 6xh plus 3h squared. Is everybody okay where that came from? Anybody not sure? Okay. Now distribute the negative 5, which will give me negative 5x minus 5h plus 4. Okay. Now I'm looking at this expression. Is there anything I can simplify still? Okay, or do I have any like terms? Do I have anything that can yet cancel? Okay. We have 2 h's, but can I combine them? No, because this one has an xh variable set. This one just has the h. And then this one's h squared. So I can't do anything with him. So I'm going to take this expression. That's the first part of my numerator. He is f of x plus h. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. Okay. Now what I'm going to do is subtract f of x. So I'm going to subtract the original function, 3x squared minus 5x plus 4. Okay. Now, in these first couple of problems, I'm putting the function in parentheses because I'm wanting you to see you have to distribute that negative. But in later examples, I'm just going to start changing the sign of those expressions. Okay. Now remember, this is just the numerator. All of this is over what? H. Okay. Now, this first part, this long expression that I came up with, remember, he is my f of x plus h. He was the very first thing we did. Then we subtracted the original problem, f of x. That's what you're always doing in the numerator. Okay. Well, let me go ahead and write this out very quickly. Let me go ahead and change those signs. Okay. Or would everybody be okay if I just drop the parentheses here? Does anybody want me to write it all again? No? Okay. So I'm just going to drop the parentheses. So that 3x squared would become negative. The 5x is now positive, and the 4 is negative. Is everybody okay? I just distributed that? Okay. Well, once I do that, do you notice anything? Okay, there's several opposites. Like what cancels? Okay, so 3x squared minus 3x squared. Negative 5x plus 5x. 4 minus 4. Do I have anything else? No. So I'm left with 3 terms up top. Now, they all have what variable? They all have an h. 6xh plus 3h squared minus 5h. Well, I'm going to factor that h out because I still have to simplify with the h in the denominator. Okay. Well, what would that look like up top if I were to do it? 6x plus 3h minus 5 all over h. So because I factored out the h, I can cancel those. This is what I've got down to from the difference quotient. 6x plus 3h minus 5. Is everybody okay how I got there? Can I go any further right now? No. Once I've performed all the algebra I can, this is when I take the limit as h approaches 0. Okay. So as I explained earlier, basically what now happens to every term containing h? They just disappear because they're going to get infinitely smaller. Remember, h is the horizontal distance between the 2 points on my graph. Well, if he disappears, what's the derivative of my function? 6x minus 5. It's all that's left. That's it. Now, if this was function f, then I'm going to go ahead and say f prime of x, 6x minus 5. And there we go. Is this starting to make a little more sense? Remember, like I said, the bulk of this is just your algebra skills, just being able to simplify that quotient. Okay, but I do want to go ahead and again make a connection. That's 6x minus 5. Here's a graph of the function we just found that derivative for. There's 3x squared minus 5x plus 4, right? Okay. Now remember, this is going to allow me to find the slope at any given value of x that I want. So f prime of x, what did we get? 6x minus 5? Okay. So let's say I'm very interested, what's the slope when x equals 2? So I'm going to go straight up. Imagine I had a straight line here until I hit it. Okay. So let's say the slope of that tangent line when x equals 2, I would just plug it in. What's 6 times 2 minus 5? So the slope of that line would be 7. Okay. That's what the derivative is going to do. Like I said, we're barely looking at what the derivative can actually do for you, but I am actually going to go ahead and show you one other thing very quickly. Okay, because you want to see something cool, right? Of course you do. Okay. You remember, I think it was about the second week of school, one of our original lessons, what would you call that point right there? Now, it is the vertex of the quadratic, but I'm thinking in terms of the function. The minimum. There we go. Remember, we had a discussion about the relative minimums and relative maximums, but this one here, we would actually refer to him as an absolute minimum because there is no y value on this graph that will be lower than that. When you're thinking about maximums and minimums, we're talking about the y values, the elements in the range, right? Well, knowing the derivative of a function is actually very useful to helping us find where the maximums and minimums occur. Let's say I go ahead and draw my tangent line for that point, which is the vertex. Well, he's going to look like that. What's the slope of a horizontal line? 0. So if I know that the slope of a horizontal line is 0, so that every maximum or minimum is going to have a tangent line that looks like that, I can set my derivative equal to 0, and it'll tell me the location of every one of those. So what is x in this case? 5/6. So I know that my minimum value occurs when x is 5/6. So then how can I easily find that minimum value? I would just plug it into the function. There you go. 3 times 5/6 squared minus 5 times 5/6 plus 4. Now, I'm not going to worry about simplifying it. I just wanted to go ahead and kind of relate that back to something we already talked about. Cool, right? I'm sure it's something you'll talk about at lunch. You won't believe what we did today in math. Here's the derivative. Because I'm sure that's what happens. Exactly. Okay. See, I know the teenage mind. Okay. I'm still hipping with it. Is that still happening? When was it supposed to happen? 2 days from now? Let's storm an active military base. Yeah, that's going to work out really well for those people.
Well, the plan eventually turned into be like a big party with tickets and stuff.
Yeah.
They canceled it completely.
Honestly, I don't want anybody to get hurt, but I really would have liked to have seen people show up. Now, I'm not saying, I want to see people gunned down as they're running across the desert, but I just really would have liked to see how many people would actually show up and do this.
They could have done it earlier, then a ton of people would have showed up, but instead of
Yeah.
What's it going to help us storm? Probably. Do you think so?
I don't know. I mean, mathematics is a universal language, so maybe that would be a way of communicating with an alien being.
definitely.
Yeah, maybe.
I don't know. When was it? It wasn't until 2000 and what that the government finally acknowledged the existence of the base? It was like within the last decade or something, right?
Might have been 06.
06, somewhere around there?
Right.
Okay. But I mean, we don't want to talk about government conspiracies. Okay. All right, let's try another one of these. F of x equals 3x minus 1. Okay. So I want to find the derivative of this linear function using the difference quotient. What's my first step? Okay, so the first thing I'm going to do is find f of x plus h. So f of x plus h. And what am I actually doing when I ask you to do that? Yeah, I'm just substituting that binomial in for every x. So 3x would be 3x plus h minus 1. So this one's going to be much easier than the previous one because it's a much simpler function. So this is just 3x plus 3h minus 1. Okay. So there's my f of x plus h expression, the first part of my numerator. Okay. So now let's start to apply it to the difference quotient. 3x plus 3h minus 1. Now, this is where I would go ahead and subtract the original function, right? I would subtract f of x. But for this one, I'm actually just going to go ahead and change the signs. I'm not going to worry about the parentheses. So is everybody okay if I say minus 3x plus 1? Is everybody okay with that? And this is all over h. Well, now what do? Okay. Here, there's only two pairs that'll cancel. The 3x's are gone. The 1's are gone. So you'll notice I have 3h over h, but those cancel. Looks like I only have 3. So this is kind of a unique one. What's the one step I don't have to do here? I don't have to take the limit as h approaches 0 because there are no h's left. So basically what it's telling me is that the slope is 3. Why does that make sense here? It's a linear function. What do we know about the slope of a linear function? It never changes. It's always the same. So if I were to look at a graph of this guy, we have him crossing at -1 with a slope of 3, so up 1, 2, 3, 1 to the right. So let's say 3x minus 1 looks something like this. Remember, by definition, the derivative is going to give you the slope of a function at any value of x. Okay? Well, because it's linear, when x is 1, the slope is 3. When x is 2, the slope is 3. That's why I got a constant here. The slope is always the same at every value of x because it's linear. It's a straight line. Okay? How we doing? Questions? Okay. All right. Now let's go ahead and try one on our own. We're ready for that, right? Yay! Jordan's on board. Okay, so I want you to go ahead and find the derivative of function g. Now, while you're doing this, I'm going to go ahead and pass back your papers from yesterday. Again, I just want to make sure, is there anybody who has not turned in your focus activities? Okay, go ahead and make sure to get those done. That is a guaranteed grade. All right. Now, I can be around. I can check the answer for you if you'd like. If you want to go ahead and double check with your villain buddies around you, perfectly fine. Let me pass back some papers. Philip. Sandra. Eli. Tori. Okay. Lane. Yes, Caution. Chloe. Okay. Jordan D. Michael's Clarissa. Hmm? Oh, if you're feeling ambitious, yeah, move on to the next one. Because it's fun, right? See that big smile on your face. Jordan. Okay, now remember this grade I took yesterday on the rational inequality exit ticket. If you did happen to get below an 80, you can retake. I've got a brand new problem over there. Just come on in and you can simplify it. Hopefully we'll get a higher score. Lane. Michael. Okay. Okay. Now you may or may not be done, so I'm going to go ahead and start taking a look at the problem. Can anybody go ahead and tell me, by show of hands, who believes they have the derivative of the function? Okay. Eli, what'd you get? 2x minus 1 is exactly what we should be getting. Perfect. Now let me run through how we got that. The first step is to determine f of x plus h. Okay, so every x is going to be replaced with the binomial. So x plus h squared minus x plus h plus 1. Okay, so again, we see that expansion. X squared plus 2xh plus h squared minus x minus h plus 1. So that's what we should be getting for f of x plus h. Okay. Now, I'm not going to worry about writing it again. I'm going to take this expression and now I'm going to subtract g of x, the original function. So that would be minus x squared plus x minus 1. And then this is all divided by h. Everybody agree so far? Okay. And then here we're going to notice several opposites. X squareds are going to go 1 minus 1, and looks like we have the x's are out. Okay. So where would I go from here? I've got a trinomial up top over my h. Okay, Jordan says factor out the h. So if I do so, that would leave me 2x plus what? Plus 1h minus 1. There we go, because h times negative 1 is the negative h. This is all over h. Those will cancel. I have simplified the quotient as much as I can. Now I take the what? Take the limit as h approaches 0. But what does that basically mean for any term containing h? It's just going to go away. So you are left with your 2x minus 1. There we go. How many people got that right? Okay. All right. Is it making sense? Can I help anybody? Okay. Now, what's really nice about this, I know I've asked, but I can't remember. Has anybody in here had experience with derivatives before? Okay. Kaushal, do you happen to know, say, the derivative of sine? But this is what you're going to start to do in calculus. If I were to give you, like, f of x equals sine of x, okay, you're going to find that the derivative is cosine of x. Now, there are shortcuts. Like I said, there are things that you can do. You may even just go ahead and memorize that fact. But the difference quotient will always get you there. I would say sine of x plus h minus sine of x all over h. Simplifying that expression will get you here. Okay. So this is really what you're going to be doing. It's going to take you further when you get to calculus, because you're going to be dealing a lot with trig functions. Okay, just kind of make you know what you're going to be doing with it. So these examples are pretty straightforward. So you're probably looking for something a little more challenging, right? Right. 1 over x plus 2, our first rational function. Okay. Let's find the derivative of this. Okay. So what's my first step for every one of these problems? Okay. So first thing is find f of x plus h. Now this one's going to be pretty easy. 1 over x plus 2 will simply become 1 over x plus h plus 2. Okay, so there's nothing to simplify there. I got my ratio. Okay, so he's going to become the first numerator when I apply the difference quotient. So I have 1 over x plus h plus 2 minus, I'm going to subtract the original function, just like we always do, 1 over x plus 2, and this is all divided by what? H. Okay. So this is the type of problem where in order to simplify the whole, you got to simplify the numerator first, which means I got to find a what? Common denominator. There you go. So again, that idea keeps coming back. All right. In fact, can anybody tell me what's the common denominator between x plus h plus 2 and x plus 2? There you go. Will's absolutely right. It's just a product of the two. Remember, h, even though he is going to ultimately get smaller, he does represent some numerical value. Okay, so I can't just discard him. This trinomial and this binomial, the common denominator would be a product of the two. So I need to make both of my denominators look just like that. Okay. So let's start with the first one. 1 over x plus h plus 2. Okay. Well, what am I missing here? Yeah, I'm missing the binomial. So x plus 2, x plus 2. And we've talked several times about this. I'm multiplying by a version of 1, x plus 2 over itself. Okay, minus, then I have 1 over x plus 2. Well, what I'm missing here is that trinomial, x plus h plus 2, x plus h plus 2. Okay. Now remember, this is still all over what? All of this is still over h. Now at this point, if you want, dividing by h, that's the same as what? Multiplying by 1 over h, multiplying by the reciprocal. I can go ahead and write it that way now, or would you prefer me to put it all over h? What would you guys like?
Put all of it.
Just put it all over h? Okay. So this is still all divided by h. All right. So let's see here. Also, one other thing. Can I go ahead and combine these fractions, or should I take one more step to multiply them together before I combine them? Just combine them? Everybody's okay with that? Okay. So this whole thing is over h. So up top, I'm going to have a single fraction where I have a denominator of x plus 2, x plus h plus 2. Okay. Now up top, x plus 2 times 1 would be x plus 2. Okay, 1 times that is the trinomial, but what do I not want to forget? When I subtract them, I need to make sure to distribute that negative. So this would be minus x minus h minus 2. Okay. Is everybody all right with that? Do you notice anything? Okay. So the x's cancel, the 2's cancel. So now I'm going to go ahead and do this. I'm going to go ahead and say we have a negative h over this common denominator, x plus 2, x plus h plus 2. Okay. But instead of dividing by h, I'm going to go ahead and multiply it by 1 over h. Okay. Well, what can I do now? Simplify on the diagonal. Okay. The h's will cancel. Now that still leaves me a negative 1. So I have negative 1 over the x plus 2, x plus h plus 2. Is there anything else I could do here? And actually, is there something that somebody is thinking about that I haven't done? It's not necessary, but could somebody be thinking about this? What am I referring to? Could we multiply the binomial and the trinomial? We could if we wanted to. It's not necessary because either way, you're still going to end up with a derivative. So I would say at this point, we can't go any further. So now I'm going to take the limit as h approaches 0. Well, there's only one h term, so he's gone. So you'll notice, what do I actually have left in the denominator? X plus 2 times x plus 2. So I would probably just go ahead and say this, negative 1 over x plus 2 squared, or you could go ahead and expand that if you wanted to. Either way is going to be perfectly fine. Okay. In fact, what was this? Was this a f function or? Yes. So f prime of x. There you go. That would be the derivative of 1 over x plus 2. So this would allow me to find the slope of a tangent line for any value of x that I want. Okay. How are we doing? Okay. Will.
Does it not work for certain points since it's irrational?
Oh, yeah. There'll be some that are going. Yeah. Absolutely. Because of the discontinuities, yes. Okay. Like right here, you can already tell there's got to be a problem when x equals what? Negative 2. There you go. And if you go back to the original function, what would negative 2 be to this graph here? He would be the vertical asymptote. So yeah, those same problems will still go fall through. Okay, good. So see, the amount of algebra you're going to do really just depends on the function that you're given. All right, so we did that one. All right, so I've got 10:44. Looks like we have time for one more. Which one would you prefer to do? The quadratic or the rational? You want to do the rational? Okay, let's do the rational. Now, would somebody be willing to come on up and show me this problem? I'll even do this for you. Okay. The first thing we got to find is f of what? X plus h. So here that would be 5 over x plus h plus 1. Okay. So that becomes my first numerator. 5 over x plus h plus 1 minus what? 5 over x plus 1, and this is all over h. Natalia, you want to do it? All right, come on up. Okay. Thank you, ma'am. Did you want the...
Oh, I'm good.
No?
Yeah.
You sure?
Sure.
Okay. At least say hello.
Hi guys.
There you go.
First we have to find the common denominator. So you have to do. Do I have to explain it all out what I'm doing?
Would you like her to explain it, or is it okay if she just writes it? Oh, Philip wants her to explain it.
Okay. So first we have to find the common denominator, which would be 5x h 1 times x plus 1.
Okay. So the denominator is going to be a product of those two expressions. Okay.
So then you just get 5x plus.
Oh.
Oh, my bad, guys.
There we go.
Okay. I'll write that later. Okay. So
Over the LCD. Okay.
would be 5 over x plus 1 times. Oh, okay. X plus h plus 1.
Good. Good.
No. Okay.
Over the denominator.
Yeah, sorry guys. Okay. So now after that you have to subtract the 2, which would be 5x plus 5. Okay. Okay.
Okay.
Minus 5x. I'm gonna just go ahead and distribute the negative.
Okay.
Minus 5h minus 5. And then
Okay.
x's cancel, 5's cancel. So then we have 5h. Okay. 5h over x plus 1 times our x plus h. Okay. Over h. But what we really can do is just do the
One detail. You're missing one detail.
oh, okay. My bad.
There we go. Negative 5h. All right.
Cool.
Let me get you some more room here.
Yeah, thank you. I'm just gonna rewrite that over here now.
Okay.
So wait, is that
Oh.
wait, sorry guys. Wait, what was it again?
So you're dividing that by h, so it's equivalent to multiplying it by
1 over h.
1 over h. There we go.
Negative 5h over I didn't really write it down this time. I just kind of went with it. So wait. Oh, okay. And you just cancel those guys out.
Okay.
So let's just pretend that doesn't exist, right?
Okay.
I'm sorry, that makes no sense. I can't explain that. So then you just have negative 5 over here x plus 1
Mm-hmm.
over.
Mm-hmm. Now we've simplified it as far as we can go. Now what do I do?
We have to apply the limit.
There we go.
This equals 0. Now we have x. Okay. X plus 1 times. Okay, no, I'm not gonna write that there. Sorry. Okay.
Oh no, that's not what I was referring to. Your plus 1 in the previous step made you think it was a plus 4. That is a plus 1.
Sorry.
That's fine. That's fine.
Okay, so I lied.
No, that's okay.
Okay.
So you're good.
Yeah.
There we go. Wait, there's just one more detail.
Oh.
No, I'm messing with you.
I'm I'm just gonna put this now. 'Cause now I'm
There you go. All right.
Oh.
It's G. That's okay. All right, she's out. But she is correct. Negative 5 over x plus 1 squared is the derivative. All right. Questions. Good job. Anybody confused? Anybody not sure how we're getting anything that we have here? Okay. Remember, when's the homework due?
Friday.
Homework's due Friday. You've only got 6 questions. This is not on the test. Okay. But you'll get your first points in the point bank if you go ahead and get it turned in on time. Remember, it doesn't have to be, absolutely correct. It just has to be completed.